Hello and welcome to Chemistry Lesson 1.09 on significant figures. We left off with the last lesson talking about accuracy and precision, and we said if we have a ruler and it has hash marks at the 1 centimeter, 2, 3, 4 centimeter mark, that if we get a value of 2.256 centimeters, and we say that we got that from this meter stick, we have a problem because it's not accurate enough to give us that many decimal places. The way that we keep track with the number of decimal places that we're allowed to have are called significant figures. And so we're going to be looking at how do you determine, when you look at a number, how many significant figures that it has. Again, this is really important when it comes to applying chemistry and physics concepts. And we talked about the rocket that blew up on the launch pad. And the reason it did that was the engineers used more significant figures than they actually measured. And so they basically created data. Well, with that, let's go ahead and jump into the rules. And we're just going to list the rules. So rule number 1 is that any non-zero number is significant. So on the left, I'll write the rules, and on the right, I will write out examples. I'll do the examples in green. So if I have the number 465, that's going to be 3 sig figs, and I'm just going to use SF to abbreviate. If I have a 52.1, that's going to be 3 sig figs. So that first rule is pretty easy. Where this can get a little bit challenging is when it comes to zeros. So there are actually 4 rules that apply to zeros. Does a zero count? Is it significant or not? So rule number 2 is that zeros in between non-zero values are significant. So if I have the number 208, because this 0 is between a 2 and an 8, that would be significant. So I would have 3 sig figs. If I have the number 15,001, even though there's 2 zeros, they're still between non-zero values. So this would have 1, 2, 3, 4, 5 sig figs. All right, rule number 3. Zeros to the right of a decimal but before a non-zero number or I should say and are not significant. I'm just going to abbreviate significant there. So if I have 0.0063, and this is probably one of the ones that's the most challenging. These zeros are to the right, but they're before a non-zero number. So these indicate, like if I had a scale that was really sensitive and it could go out to 4 decimal places, I put something on there that was 6.63 hundred thousandths of a gram. So I didn't really measure these, but it indicates that my device could go that far. So these don't count, and this number has 2 sig figs. What about 0.0802? This 0 is in between 2 non-zero numbers. So this 0 counts. But this one is to the right of the decimal, but before a number, so this one does not count. So this guy has 3 sig figs. All right, rule number 4. Now the next two have to do with zeros at the end of a number. Rule number 4, zeros, what if it's Z-E-R-O-E-S? I might have spelled zeros wrong on this entire thing. Well, I'm going to stay consistent. Zeros, let's see, we're going to say at the end instead of to the right. And you know, it is ES, Z-E-R-O-E-S. My goodness. Zeros at the end of the number without a decimal are not significant. If I didn't need this video for tomorrow, I would re-record it. That's going to bug me. Here's our example. If I take 120, blue. If I have the number 120, I don't know if the piece of equipment that I use to measure this can actually go out this many places or if this was just estimated. So there's no decimal here, and that tells me I'm not sure about this. So this would have 2 sig figs. If I take 1,000, this would actually only have 1 sig fig. There's no decimal here. Okay, finally, rule number 5. Zeros at the end of a number with a decimal are significant. So if I have the number 15.00, that tells me that my device could measure, this could have been 15.22, it could have been 15.05, but it just happened to measure 15.00. My instrument is capable of measuring this. So because of that, that's going to have 4 sig figs. What if I take 1.0? So this means that I could measure to the 10th place, and this would have 2 sig figs. Well, why do we care? Why is this such a big deal? And the answer is we have to consider mathematical operations. So the reason we do this, usually or sometimes classes will talk about both addition, subtraction, and multiplication, division. We don't do a whole lot of adding and subtracting of sig figs, so we're just going to talk about multiplying and dividing. And significant figures are always abbreviated sig figs. Give ourselves a title up here. These were the rules. All right, so let's do some examples. And I'm just going to write out this direction. So let's go with example 1. So if I take 208 and I divide that by 120. So when I punch that into my calculator, which I'm doing right now, I get 1.733333. Well, we said earlier that this has 3 sig figs and this has 2 sig figs. Here's the rule. When you're multiplying and dividing with sig figs, your answer can only have as many sig figs, whoops, as the least multiplier or divider, as the least starting number. So even though my calculator says 1.7333, I'm going to write this answer as 1.7 because that's 2 sig figs and I'm only allowed to have 2. That's my least number. All right, let's go to example 2. Let's take 52.1 times 0.0063. And when I punch that into my calculator, I get 0.328. So this isn't what I'm just going to write down everything I get. I get 0.32823. Well, what am I allowed to report? We said this has 3 sig figs and this has 2 sig figs. So that means that I can only have 2. I'm going to put 0.3 and then I have a 2, but since this is an 8, I'm going to round this up to 0.33. All right, let's do one more sample problem. Let's take 6.02 times 10 to the 23rd. Let's divide that by 1.0 times 10 to the second. When you're doing scientific notation and you're talking about sig figs, you do not look at the exponents. You look at the operators. So I know that 6.02 divided by 1 is going to be 6.02. But when we look at this from a sig fig perspective, this has 3 sig figs, because this 0 is in between a 6 and a 2. This has 2 sig figs. The 0 is to the right of a decimal, so these both count. So if I was going to write this with the correct number of sig figs, I would have to say 6.0, because I can only have 2 sig figs. And then I would put my 10 to the 23rd divided by 10 to the 2 would be 10 to the 21st because I subtract my exponent. Oops, and I cut that off. Apologies. Rewrite that. I think I need to start trimming my paper. All right, so that should be all the information that you need to finish this homework packet. You're going to finish page 8 and 9 for your assignment, and then you will be reviewing that when you come back next week. And if you have any questions, please email. Thanks for watching and have a great day.